So it's 3 o'clock here in the Netherlands, and we're going to start. Welcome everyone. Welcome to today's Energy Tech Talks. My name is Erik Nijveld, CEO and co-founder of technologycatalog.com. Today's webinar will be delivered jointly with Daryan Taher, Reservoir Engineer at Serafim. If you have any questions, please type them in the Q&A box that you see on the left-hand side. And we will go through the Q&A following Daryan's presentation. But before handing over to Daryan, let me share a few updates about technologycatalog.com. And for that, I'll move to full screen. And you should all be able to see it. So most of you in the audience are probably familiar with technologycatalog.com already. But in short, with the platform, we help companies around the globe with efficient identification of technologies to solve today's challenges. And by now, we have over 10,000 energy professionals around the world using the platform. And some of the companies that have a subscription with us are listed with the logos at the bottom of this slide. We continuously make improvements to the platform, and the latest advancement is Steve, our AI assistant. At the end of this webinar, I'll give a quick demo of Steve. Here you see a screenshot. With this functionality, you can type in challenges, and you can ask Steve to come up with solutions. Steve proposes a maximum of 6 solutions, and then also indicates which solution has the best fit and the reasons why. And with this new development, it has become more efficient and easier than ever before to find the right solutions for your challenges. In case Steve is not able to come up with a suggestion yet because it's not yet on our platform, then the other option that we offer our users is to post a challenge. Here you see a screenshot of the challenges that are live at the moment. Most of the recent challenges were posted anonymously. However, based on the location, you can have an indication in which area the deployment needs to happen. And as a supplier, you can respond to these challenges, and this way getting in direct contact with the challenge owners. It's a great way to attract potential buyers for your solutions. For the end users, it's a great way to find out what's there available to address the challenges with solutions out there. We've also made some updates to the packages for suppliers. We've simplified it, and at this stage there are 2 packages that we offer. What's called Basic, that's an easy way to join the platform, free of charge, and then what we call Accelerate, which offers more features and gives you better data and better functionality to create visibility and generate leads. So with that, I'm going to hand over to Daryan. I need to stop sharing screen. And once I've done that, Daryan, I'll make you the presenter.
So Futures is the flagship software that Serafim Limited has created about 2 decades ago. And first of all, Serafim Limited was founded in 2000 with the vision of improving oil field planning through the greater use of mathematics. And we've built on that for the past 24 years. And we have built a team of expert engineers and mathematicians with various roles at the company. But our main area of focus is Futures, which is our flagship software for a digital twin solution. So to give you an overview of futures, futures we think is the world's first general purpose asset model. It's ever since 2003, it has been in development, continuous development, and it has been used by oil and gas companies as a production forecasting solution, and also as a general purpose, a higher asset management tool. And with futures is really time tested, and it has been developed alongside the needs of the reservoir engineers, production technicians, and business analysts, and a range of other positions in the oil and gas companies. So we've been in parallel to the needs of the customers that we've had, and that way we have been always the newest solution, the newest functionalities, and all of the new functionalities has been at the request of oil and gas companies. So it's really from the user's perspective. So we know that the functionality and the new functionality we've put in actually make a difference, save time, save money, and make the lives of reservoir engineers and production engineers and production technicians easier. And it's not just new software, new tech, new functionalities for the sake of pushing updates. So the term process digital twin has been used to describe what we are saying, general purpose asset modeling software. It basically, from reserves estimation to business planning, futures covers a range of aspects of the oil field management, and we will hopefully get to that in the demo we have prepared for you. Now, integrated asset modeling versus general purpose asset modeling. In traditional integrated IAMs, or integrated asset models, are complete in their definition of the oil field, or the definition of the oil field management, but they're limited by their runtime and by their speed in which, because of old algorithms and because of old solvers, they're limited by that in the definition that they provide. Futures, on the other hand, combines that completeness of the oil field management with speed. We have an SPE paper that shows that futures was 1,000 times faster than network solver and solving the network compared to the mainstream competitor, which is ideal it's ideal for wide-ranging forecasts if you have multiple forecasts, but it's also ideal if you want to have a reasonable definition of your corporate network, because as you can see from the two case studies that I'm going to explain shortly, if you have a solution, or you have many solutions that have to work together to give you the answer you're looking for, it's going to take more than 2 days, 3 days to get to the answer you want to get to, and that's simply not efficient, simply not robust. It makes the lives of reservoir engineers and the business planning much harder. The result of futures is rapid and accurate decision making across all time frames, from daily operations to long-term planning. In terms of capabilities, what does futures do? Well, it has versatile forecasting. So futures has short-term, mid-term, and long-term forecasting for covering production and cost projections. And this is important, and this is basically, especially for the long-term forecasting and covering many time steps and having monthly time steps or sometimes daily time steps if necessary. That's perhaps made because of the engine that runs behind futures, and we'll get to that in a second. It covers end-to-end coverage. It has end-to-end coverage from reservoirs to cell point, and we have incremental sales calculations on that end, and we have the ability to tie it to simulators on that the far end. So it manages well potentials, facility constraints, and what you expect from IAM calculations you're going to get with futures. Now, advanced futures, as I said, futures is in continuous development. So each year, every 6 months, every year, based on the needs of reservoir engineers around the world that are using futures, we add new functionality. That includes probabilistic calculations, Monte Carlo based. That includes power and greenhouse gas emissions estimations, and that includes injection and production links. All of which are crucial if you want to have a modern definition of your IAM calculations. Futures is an integrated workflow. So we have built-in tools to streamline processes, and it enhances efficiency and reduces errors in complex operations. The engine that runs futures, or this network solver behind futures, is Gale. Gale is globally approximate, locally exact. It stands for that. It's an acronym for that, which is a domain-specific algorithm optimizing linear objectives with multiple constraints. Now, we've managed to build Gale in-house for utilizing sequential linear programming, and it linearizes solution points of local nonlinear problems. This has drastically improved runtimes in comparison to the old methods of traditional integrated asset modeling solutions. Now, in reality, what has this done for us? Well, as I mentioned in the SPP paper, we have the SB 200-754. We managed to solve 361 wells in 0.14 seconds per time step. So that's a huge improvement to basically any traditional IM that is out there. And the great part about all of this is that it's robust. So you're not in the fear of waiting 10 hours for a forecast and in the 9th hour the software crashes. No, the solver is very robust. The software is very robust, so you won't get a lot of crashes. Now, if I can move to the 2 case studies that, as I explained, futures has been in use by oil and gas companies for the past 21 years, since 2003. And what that means is that we've had many cases of successful stories in which futures was a major improvement for the oil and gas company. So I've selected 2 of those to talk about. We had a large oil company with wells dating back to the 1920s and historical data for that wells. They had a workflow that simply didn't work. So what the previous forecasting workflow for that company was that they had a gap model they have multiple assets. They have 3 assets, and then they have a separate one, not an asset, but a separate network for the customers, so the LNG and stuff. So basically, they had 3 assets, and for asset 1, they had a gap model of that asset with pressures feeding into. The company had a proprietary model of overall gas systems. So for asset 1 and asset 2, and that fit into the proprietary model of total on oil and gas production that defined the whole field. Now, that was simply not working according to the engineers, because it took 48 hours minimum to run, and it was error prone, crash prone, and it just simply didn't work. So they came to us, and we started using bit by bit, started transforming bit by bit their system that they had into futures. And what we ended up with was a single system. So no longer they needed, so in terms of cost savings, they no longer needed to maintain and support the other 3 models, the other three softwares they had. So they have a single system now with hundreds of reservoirs, thousands of wells, oil and gas. They have the 3 assets defined with great complexity. I'm going to show you a anonymized model of their corporate model right now. It's anonymized for privacy reasons, but in terms of the complexity of the pipelines, of the nodes, of the platforms, of the wells, of the separators, it's all, you can see how complex it is. They have a mix of customers that are all modeled in futures: LNG, power generation, methanol plant. They're using futures for short-term, long-term forecasting, obviously, but also for power, stochastic, and incremental sales calculations, and a range of positions amongst the personnel at the company is using it: reservoir engineers, technicians, production technicians, and all of that, business analysts, and all of that. And with all of the complexity and with multiple forecasts running, it takes about 2 minutes and 30 seconds to run a forecast of futures. And you can imagine that in terms of time saved for reservoir engineers, for the engineers who are using it, you're expecting to, the management is expecting a certain forecast from you, and you used to tell them, see you in 2 or 3 days. Now you can say, I'll get that to you by lunchtime, and even before that. And that's what futures brings to the table. And this is crucial in terms of the runtime, robustness, and in terms of how complete the overall system is. To show you, so this was a speed test, monthly time steps for 28 years. And as you can see, it took us 2 minutes and 30 seconds. And this is the network diagram that they have. As you can see, all of this is asset 1, 2, 3, and this is their customers. So, and they have modeled everything, constrained where it needs to be constrained, and all of that. So that's case study 1. Case study 2 is a bit different, because in the second case study, futures was implemented early on, not from the get-go, but after a few years it was implemented. So futures has been used throughout much of the life cycle, and even when companies changed hands, futures still managed to continue working for the company. What the use of futures, what did it add for the company? First of all, futures provided for them real-time insights into how constraints impact production, and ensuring alignment with facility capacity. So in terms of design, in terms of knowing how they are an offshore field. So being offshore, you're space constrained, you're power constrained, you're everything constrained. So they knew what their platform could handle. They knew what their export lines could handle. They knew everything, and they modeled that, and they figured out what to do in terms of design. And the optimization in futures reduces the impact of excess capacity, reducing downtime, reducing environmental impact, reduces all of that because of optimized resource allocation. The result is maybe this is something that they don't feel on the daily use, or maybe this is something they don't think about on the daily, but I mean, our estimation is that they have indeed saved millions and millions of dollars, tens, if not hundreds of millions, because of using futures. They now have a highly constrained system without the need to build excess capacity. They have just the right capacity, just the right power lines, just the right separator sizes, just the right pipelines and everything, because they can forecast accurately and very fast how every bit of the design works. And I talked about saving time in the previous case study, and obviously time is money. So you save passively you save time in case study 1, but in case study 2, because you're not paying many more millions to build facilities that you probably will not need. Instead of that, it's better to have a highly constrained system that works and costs you less in capex. They have saved quite a large sum of money by using futures. I'm going to be showing you in the demo a anonymized model of what I'm talking about in case study 2, so you can see for yourself how long it takes and all of that. In terms of futures, ever since 2003, we've had global adoption of futures, so many people are using it, including Repsol, BSP, and CNOOC, and Tello in UK, a lot of customers in the North Sea and in the Middle East. In terms of support, our support team spans from the UK to the Middle East to the Philippines, so we can cover a range of time zones in terms of response. We usually respond to bug fixes. Our rule is, which we almost never break, is that we can fix a bug under 24 hours. And we actually have 2 versions of the software. So one is the fixed version. So that's one iteration behind the adaptive version. So you always don't get the newest features in the fixed version, but it's the stable version always. And we offer with futures our expertise and in consultancy, because at the end of the day, we are also reservoir engineers and not just future specialists. And something I talked about a lot is that our original development team behind futures is still with us. So any new functionality, as I mentioned, is going to get implemented in a small time frame. So I will show you a demo of the case study I was talking about. It's anonymized, but you'll be able to see. And I also demo the general use of futures. So this is futures version 7.2. Now, I wanted to show it in this version, which is a beta version, as you can see, because I wanted to show you the continuous development of features. So the linear solver, so the network solver is in-house, and I mentioned, is developed in-house and contributes the speed of futures. Now, the linear solver in futures is one of our customers came up to us and said they have a very large network and they have a pressure network and all of that, and it's highly constrained. And they came to us and said, if we run multiple forecasts, it takes us 40 minutes to run the forecast in its entirety. And we want to make that, if you can make it less. So we got to work, and we have now this new linear solver that takes it from 40 minutes of runtime of multiple forecasters, including pressures, and it now runs in under 7 minutes. And that's in version 7.2, the beta version I'm showing you right now. So that shows the constant development of features that because of the fact that we have the original developers behind features still with us. You have, much like the Microsoft suite, you have a ribbon UI, and the good thing about features is it has seamless integration, either with first of all, it's very easy to create your network in futures. You can just create it from Excel, provided that you have the wells, reservoirs, and fields in the right format that futures wants. But then after you have created it, you can have seamless integration. For example, you can link features to a database, and for example, OFM or whatever, or to simulation files in terms of the production data, or to Excel. You want to import from Excel, and the same goes for well test data. Now, again, on the other side of things, in terms of integration, you can just export your profiles to Excel or to any of these two reserve softwares, or you can look at the reserves and then export them as well. To show you how complex the network is and where can you go with things with futures, this is one of the network diagrams for the clients. And as you can see, this is only one of the, as you can see, the lines in which things lead to. And for example, this is detailing pumps, separators, and compressors, and power lines, so power generators and power consumers. And obviously it also models the nodes, which are platforms that continue. For example, this one continues 32 wells. This is the production network. I mentioned the gas injection and water injection network integration. So this is one of the things we've added recently. So as you can see, some of them have arrows pointing towards them. So that means they have a link between the injection, or a link between them and the production network. The same goes for gas injection as well. So what I'm going to show you is, for example, I can show you the field total. So I've already run this model. It took about 2 minutes and something. I've already run the model, and as you can see, we have a constraint model in here in which the oil is limited to 200,000, and as it shows with the red dot in there. So now what I will attempt to do is I've deleted the constraint on the oil rate, just to show you the speed of things and how easy it is to make changes. So this used to be 200,000 barrels per day as a maximum capacity constraint. So we deleted that one. And now we'll attempt to run the model. So it's showing 1 minute and 5 seconds in terms of runtime. This model has about 1,000 wells, I think 1,100 or something like that. Highly constrained. 2 forecasters, one for a rate forecast and one a pressure forecast. It also has power generation and power requirements. It has greenhouse gases. It has your lift curves imported and all of that. And I think the forecast is till 2043, if I'm not mistaken, or maybe even more. So as you can see, it's going through each time step, and it will be done in under 2 minutes. I'll be happy to answer your questions in a second, alongside my colleague and the founder of the company, Peter Cunningham, who is also one of the developers behind Futures.
Hey, thanks, Daryan, for the presentation. Are you still want to wait for the outcome of the simulation before we go to Q&A? Or are you okay?
Well, it's hopefully not going to take long. It's another 20 seconds, 30 seconds.
So once done, we'll stop sharing your screen and also give Peter access. And we can then go into Q&A. And for those of you in the audience, if you have questions to Daryan or to Peter, the Serafim director, please type them in the Q&A box, which you find on the left-hand side of the screen.
So as you saw, 2 minutes and 33 seconds, and back to 340,000 in terms of the. So what you basically saw is how easy it is to make changes and how easy it is to make mistakes. Most of the time it happens that you can make mistakes in modeling and in calibration, pressure calibration, and all of that. With other solutions out there, a mistake could cost you a lot in terms of your time. With Futures, it's a matter of minutes. So thank you, Erik, and everyone. I'm gonna stop sharing, and we'll be open to the questions you have.
Yeah, thanks, Daryan. Let me first see if I can give Peter access. So he should be able to join with video in a moment. Hi, Peter. Yeah, can you hear us okay?
Yeah, I think you're on mute.
Yeah.
Okay.
Yeah, excellent. Welcome, Peter. And so it's great that you're joining this Q&A session. So, and for anyone in the audience, if you have questions, please type them in the Q&A box. But let's start with a couple of questions. So, Daryan, you presented 2 case studies. Can you say a bit for which type of study you see most traction? Because you can imagine that these are quite different audiences in the client organization.
Which case study do I see most what?
Well, you presented 2 case studies, quite different case studies. For which case, for which type of application do you see most interest in the client organization?
Yeah, well, I guess they are very different, but I think there would be interest and attraction to both of them because we have clients that we're talking with that they have solutions that are just like case study number one that are just not working anymore because of how the historical data has added up. The range of forecasts and the range of possibilities have increased. Management wants to see more options, and they want the time frame has shortened. So they want in a month's time or 2 months' time or 6 months' time to see so and so. And the Reservoir Engineer has many tasks to do, including this one. So transferring their or moving away from these traditional solutions to futures could be a good idea. Granted, it could take a bit of time until things get to a point in which they can smoothly run. But don't forget, we are a consultancy and we provide after-sale services, and we can make your model. We can create your whole model for you in futures. As for case study 2, yes, I would imagine companies acquire new assets all the time, and they drill in new locations all the time. So interest in that happens as well, in which a company comes and has a new asset, and they want to start on the right path from the beginning. So yeah.
Thanks. A question has come in. Given a reservoir engineer with, say, 3 to 5 years of experience, typically how long would it take them to learn the system and become productive with it?
Peter, should I take it, or do you want to take it?
I might give a quick answer because we had some of our customers, in fact, gave an answer to this question themselves. Their experience was that it took about, in a company that was already using the software, so with experienced users around and with the models already in existence, took about 2 weeks to get up to a good standard in understanding the software. If you're starting by yourself, and then it takes a bit longer, because then you have to examine, the key aspects of designing the model and making the choices.
Yeah, if I can add to that as well. Case in point, we've had a new customer the past few months in our company in the North Sea, and one of their engineers who have been working remotely in his hometown has started using futures. And I think obviously they have other tasks as well, not just futures, but with our help, with us being available throughout the time, I think he got up to speed with futures in about 2 months' time. He's in a remote location, so there aren't other engineers to help him, but we tried to help him, and he got up to speed in about a couple of months.
Okay, so that's excellent. So people learn how to use it fairly quickly. Yeah. Another question, are you considering any software enhancements involving AI/ML?
Peter, do you want to?
Daryan this happens to be a subject that Daryan is particularly keen on. At the moment, our thoughts are that the AI would be useful as an additional help resource. And we've been looking at AI systems that are oriented towards that, towards providing application help. But we haven't found anything of an immediate impact. In some respects, in terms of machine learning, the automatic decline analysis is uses some of the same basic algorithms, albeit in a rather more tailored form. So it's the general principles behind it are certainly relevant, but it isn't yet directly implemented in futures.
Okay, you're keeping an eye on it.
Yeah.
Excellent. Hey, and are there sort of perfect candidate assets for your solution? I mean, I can imagine you do need a certain degree of complexity for people to look at futures. Is that correct?
I would say there are two things where it would be particularly useful. One is where you've got a significant problem with existing workflows. So if you're finding yourself that your forecasting is becoming a burden, is taking a long time, you haven't really got a control over precisely what's happening because runtimes and whatever, then future could be of significant benefit. But the biggest benefit, I would argue, and this comes back to your question of which of the two case studies, I think the biggest possible benefit, the biggest benefit of it is to enable the design of more complex production systems, or rather production systems that operate in more complex manners. So if you don't have a method of predicting the behavior of a highly constrained system, then by and large what people do is, well, then they say, well, if we're highly constrained, we don't know exactly what's going to happen, but we think it's not going to be good. We're going to lose oil. So therefore, let's make sure that we're not highly constrained. Let's build enough space in our facilities that we can, all of for this in our current location, that it can handle all of the stuff and so on. Whereas what happened in the case study 2, with a method of analyzing and understanding the effects of complex constraints, what the oil company found is that up to a certain point, constraints are not that expensive because you simply shut in some of your older wells or prioritize and so on. And so they found their asset has been developed in a more complex manner than usual, using, and what's it's enabled them to do is to save significant sums of money in terms of facility sizing. So they have pipelines sending stuff all over the place to take advantage of it's a small bit, you can put, if you've got a new field coming on, well, don't size it for, you can put a smaller thing and then send, in years of peak production, send it to another existing platform, and you just have to shut in some of that production. So that's where the big savings will come, is from using it for facilities, design of complex facilities. But in more immediate thing is, the most immediate benefits are solving when you have difficulties with your existing systems.
Yeah, thanks. Hey, building on this, another question: are there any types of asset configuration which are problematic for future to generate robust forecasts?
where future would be least beneficial is where you've got a single reservoir with complex behavior. And it's not that future couldn't handle it, but it's just that there wouldn't necessarily be much benefit to it, because the simulator captures is a good description of what's going on, and you can just run your simulator. So where futures is beneficial, is essentially beneficial where the detailed reservoir or process models prove to be, don't give you the final answers. So for example, you've got, so let's say you've got a constrained network and not one reservoir but 20, and you've split out amongst 10 reservoir simulation models and 5 wells that are just forecast with decline. You can't get the answer from the simulator because you don't know the amount of back out and so on. And so that's where future is most beneficial.
Yeah, excellent. So there are no more questions in the chat box, and yeah, great presentation. So thank you very much, and also thanks for the clear answers. And it's really great to see the development over the years. So the first time we met and spoke about this was probably about 6 years ago, and it's really impressive to see the progress made. So many thanks. And in the remaining 10 minutes of this webinar, I'll give you a quick demo of some new functionality that we introduced on technologycatalog.com. So Daryan and Peter, if you can switch off your video, I can probably also do it from here.
Okay.
And let me share my screen. So if correct, you can see the homepage again of technologycatalog.com. Indeed coming up. Yes, it's there, I can see. And as mentioned at the start of the webinar, yeah, we're continuously making improvements to the platform. The latest advancement is the introduction of Steve, our AI companion. So this is accessible for users that have a premium subscription with us, and we're in the process of rolling it out to those users. So the moment I go to my own homepage, which I can access by clicking on the icon, the toolbox icon in the top right, Steve appears on the left and also at the top. And by clicking on it, I can type in a challenge and ask Steve a question. For example, I can say I'm interested in a solution for production forecasting for assets with large number of wells. So that's, for example, that could be my question to Steve. I'm then going to press the button. It takes a little bit of time for Steve to come up with solutions. Steve is going to propose a maximum of 6 solutions. So we don't want to overwhelm the people that are seeking solutions for a challenge. So maximum 6. And Steve is going to go through the content on the platform. So in this case, Steve was quick. So you can see his response already on the platform. So in this case, indeed, futures came up as the best technology. So Steve says, indeed, futures is the most suitable solution for this, and these are the key reasons. So it gives a couple of bullets here why this is the most suitable solution. And by clicking on futures in this case, it goes straight to the page on the platform where you can find information about the solution. So this is just a quick demo. The initial response that we got from our users was extremely positive. With this improvement, it's easier than ever before to find solutions for challenges. If you'd like to learn more about this, please contact us. Please drop us a message by sending an email to info@technologycatalog.com. If you have any questions about this, please type them in the Q&A box and we can answer them now. Or if you have a specific question you would like to ask to Steve, we can also do another live demo here. We've tested this quite extensively, and in most cases, Steve comes up with a suitable solution. In case a suitable solution is not yet on the platform, then companies that use our platform, they can then post a challenge. And at the start of this webinar, I showed a screenshot. But by clicking the challenge button, you see all the challenges that are currently live on the platform. And as a supplier, you can respond to these challenges. So that's a quick demo. Let me have a final look at the Q&A box. I don't see any further questions or further comments. So with that, I suggest we close this webinar. Thank you very much for attending. Also, some people based in the Americas attended, so wish you all a great day. And for those of you that are in the East, wish you a great evening or great rest of the day. And thank you very much, and looking forward to seeing you during the next Energy Tech Talks, which will happen early in the new year. So bye for now, and thanks Daryan and Peter once more for the presentation. Many thanks.